So in this question we're going to calculate the variance of the Rayleigh distribution. Now the Rayleigh distribution has got this PDF here, x times beta squared e to the minus beta squared x squared over 2. And the random variable is always greater than 0, and the scale parameter is also greater than 0. So to calculate the variance from this PDF, now the way we do that is we find e of x squared. Let's do it over this side. So e of x squared, that's our first mission. And then we subtract from e of x and that squared. Now these two are different calculations. Now in the previous video we calculated e of x. So if you check the link below you'll see how we got to the mean of that. So just to note, this is the variance. Now the mean, that's e of x. In the last video what we calculated that as 1 over scale parameter beta multiplied by square root pi over 2. That was our result of e of x. So if we just square this, that's going to give us our e of x squared, but we need to calculate this e of x squared. Now the way we can calculate that is through integration of this PDF. Now in the previous video for the e of x, what we did was we got e of x equals the integral from negative infinity to infinity, and we changed that from 0 upwards because x is always greater than 0, so there's no integral below 0 anyway. So we went from 0 to infinity, and we multiply that by x times the PDF of x given beta dx. Now in this video we're going to try and find e of x squared. That's going to be our main integration. So for e of x squared we now need to multiply our PDF by x squared and integrate it. So all I need to do now is just plug in this PDF in here, and then let's see if we can integrate it. So then this equals from 0 to infinity, our PDF is x squared times this. Well, I've got an x there, so I'm just going to write the x squared next to the x, that's fine. And then beta squared e to the minus beta squared x squared over 2, and then integrate with regards to x. So I've got x squared times x, so that's nice and clear so you can see what's happened there. Okay, so how am I going to integrate this? This looks really complicated. So the usual place to start is with what's inside the exponential when you've got an exponential function. Now the beta squared, that's just a constant multiple, and the minus I'm going to leave. So I'm going to do a u substitution. I'm going to let u equal x squared over 2 and go from there. That's going to be my first place to start. So u equals x squared over 2, and then as it's a u substitution I now need to find my derivative. So my du, so derivative of this with regards to x, x squared becomes 2x. 2x divided by 2, that's just going to leave me with x. So that leaves me with x dx, and then my dx is du over x. Now that's already looking good because I've got an x there which is going to cancel with my du, and my x squared is u equals x squared over 2. So to get x squared on its own, I'll get x squared equals 2u. So I can substitute that in for my x squared. So let's go with that. And also my parameters at 0, u is still 0, and at infinity, I've still got infinity. So my parameters aren't going to change either. So 0 to infinity, x squared is 2u. X I'm going to leave in because I've got a cancellation coming. Beta squared, that can stay there. And then I've got e to the minus beta squared, and then x squared over 2 is u. So I've got minus beta squared u. And then my dx is du over x. Okay, now my x's can cancel, so that's great, that's what I want. So now I'm just going to write this again, and I'm going to bring my 2 times beta squared out of the integral as well, just to make things a little bit tidier. Okay, so 0 to infinity. Make a space for my 2 beta squared. And then with that out, my u will stay. My x will cancel, so that takes care of that. And then I've got e to the minus beta squared u du. Okay, so now I've got this function here, u and e to the minus b squared u. I've got a function of u here and a function of u here. So my next port of call is going to be integration by parts. So I'm going to split this up into a u and then an e to the minus bx squared. So if I set up my integration by parts formula, I'll have integral of f times g prime equals fg minus the integral of g and f prime. Okay, so I know to set up which I want for my f and which I want for my g prime. So u I can integrate or differentiate, but this function here I can differentiate, but it's going to be even better if I integrate this one, because then I can get my beta squared as my in my denominator, which can then cancel out with this beta squared. So that could be a good option. So I'm going to let f equal u, which means my f prime is just 1. So that's going to be great when I'm doing my second integral here as part of my answer. And I'm going to let g prime equal this. So that's my f and that's my g prime. So now g prime equals e to the minus beta squared u. So therefore g, take the integral of that, that's going to be minus e to the minus beta squared u, and then divide by beta squared. Okay, that takes care of that. So now let's follow this integration by parts formula and just go on this line here. So now I've got 2 beta squared. So let's put that in there. And then that's going to multiply the whole thing. So f g prime, that is that. So this is now part of my answer. So on f times g, which is u times this. So I've got minus u e to the minus beta squared u over beta squared. So that takes care of my f times g. And then from that I subtract my next integral, which is g and f prime. So f prime is 1 and g is this function here. So that takes care of that. So minus e to the minus beta squared u over beta squared, and then that's du. And now, because I've got parameters, I need to plug in 0 to infinity as my parameters. So my integral will need those parameters. And this here, as part of my answer, this here will also need to be calculated over those parameters as well. Okay, so simplification, what have I got? Well, minus and a minus, they will cancel out, so that'll leave me with a positive. And this beta squared can come out. And as this whole thing, let's just put that all in brackets just to complete it. This beta squared can cancel out this beta squared for the integral part. But then this bit here will still need to be multiplied by 2 beta squared. So let's go on the next line and see what we've got. So now I've got 2 beta squared. Right, what we got here? So at infinity, if u is infinity, I've got negative infinity. But this e to the minus beta squared times infinity, this will just get to 0 with u approaching infinity. So this top line is infinity. So therefore I've got 0 in there at infinity. And then if I plug in 0, my u is also 0. So therefore this whole thing is just 0 minus 0. So this thing will just cancel out at those parameters. So that just cancels out. So then that just leaves me with my integral. So I've got minus and a minus. So that just leaves a positive. And then I'm going to integrate from 0 to infinity e to the minus beta squared u over beta squared. Well, I don't have to put that beta squared in. I can just cancel out that because this is 0. So this beta squared will just cancel out as well. So I can just cancel that beta squared out along with this one. So basically what we'll have is this one and this one will cancel out, and I don't need that. Okay, so that's where we're up to. So now what I'm going to do, I'm going to take this off the board up to the top, and then we can continue with this integral. Okay, so here's our integral now. So 2 times the integral from 0 to infinity e to the minus beta squared u du. Now, beta squared here is just a constant in terms of our integration. So this we can integrate straight off now because we've got e to the minus u. We can go with that straight away, and 2 is our multiple. So let's go for that. So now I've got 2 times e to the minus beta squared u. Well, the integral of that, I've got minus e to the minus beta squared u. My input will still stay the same, but now I need to divide by my beta squared. So that takes care of that, and then I calculate it from 0 to infinity, and that's going to give me my result that I need. Okay, so at infinity, what have we got at infinity? So we've got 2 times minus e to the minus b squared times infinity. Well, this is going to approach 0. So this at infinity is just 0. So that takes care of that. And then at 0, when u is 0, I've just got e to the minus 0, which is e to the 0. And that is just 1. But with my minus sign here, I've just got minus 1 over b squared. So I've got minus, and then here I've got, so I'll just put that for my infinity value, minus 1 over beta squared. So if I just make a note here, that's at my infinity value, that's at my 0 value. Okay, well now we can just calculate straight away what this is. 2 minuses make a plus, so I've got 1 over beta squared times 2. So therefore my e of x squared is simply 2 over beta squared. So that's great. So now I'm straight away now I can go into here and calculate my variance. So my variance is e of x squared, which is 2 over beta squared, and then subtract that from this squared. So now I've got 1 over beta times the square root of pi over 2 all squared. Okay, well to square this, I'll lose the square root of pi over 2, so it'll just be pi over 2, and 1 over beta will become 1 over beta squared. So this now becomes 2 over beta squared minus pi over beta squared times 2. So beta squared times 2, so I can write that as 2 beta squared. Okay, now I've almost got common denominators here. I just need to get a 2 in this. So if I multiply this by 2 over 2, so if I put a 2 over 2 here, 2 over 2, and multiply this by 2 over 2, I'm just basically multiplying that by 1, so I'm not affecting anything. So then that's going to give me 2 2s are 4, and then minus pi. And then my common denominator now is 2 beta squared and 2 beta squared. So it's just 4 minus pi over 2 beta squared. Okay, so then that's going to give me my variance. So my variance is 4 minus pi over 2 beta squared. And that is my answer. That's my variance of my Rayleigh distribution. Okay.